Factored form of a quadratic equation. Our learning goal today is to use the factored form of a quadratic equation to find the x and y intercepts and to graph the parabola from this form. Please ensure you have the lesson printout so you can follow along with this video. There are various forms of quadratic relations, which include the factored form, which is in the state y is equal to a bracket x minus s close bracket x minus t close bracket. The vertex form, which is y is equal to a x minus h close bracket squared plus k, and standard form, which is y is equal to ax squared plus bx plus c. The latter two we'll talk about in other lessons, but for now we're going to focus on the factored form. And from the factored form, there's a lot of information that we can easily get and calculate, like the features that we looked at, the y-intercept, the x-intercept, and the axis of symmetry. And it's going to allow us to graph the quadratic much easier than having to fill out all those table of values charts. So let's get into it. Let's graph the following quadratic relation using a table of values. Our equation is y is equal to 2 bracket x plus 1 close bracket bracket x minus 3 close bracket. To use a table of values, what we do is just replace wherever we see an x with the value that's in the table of values to get our y. So let's try the first one here. We have y is equal to 2 bracket negative 3 plus 1 negative 3 minus 3 close bracket. And just following Badmus, we have to do the brackets first. So we'd have y is equal to 2 bracket negative 2 bracket, it's going to be negative 6. And then we just have to multiply through. Y is equal to 2 times negative 2, which is negative 4. And then y is equal to positive, 2 negatives make a positive, 24. So this is going to be 24 here. Kind of a lot of work. Let's try the next one here. Y is equal to 2 bracket negative 2 plus 1 bracket negative 2 minus 3. And let's just go through that. So we'll do the brackets again. Y is equal to, this is going to be 2, this is going to be negative 1, this is going to be negative 5, and then we multiply through. Y is equal to 2 times negative 1, which is negative 2 times negative 5, and then we'll get an answer is y is equal to 10. Okay, so we have our second y value. It takes a lot of time. I'm not going to do any more. You can just copy the rest because I have them ready for you here. So if you plugged in negative 1, we get 0. We get negative 6, and then just imagine how much work you have to do all of these. 8, negative 6, 0, and 10. Okay, so those are all our values here. So now we're ready to graph our parabola. There's a lot of points here we could put down, but we can simplify this process. All we need to do is find the major features of this parabola. Those are the x-intercepts, the vertex, the axis of symmetry, and the y-intercept. Can you see anywhere where y is equal to 0? That would be our x-intercepts. That's right, there's one right over here. So negative 1, y is equal to 0. Is there another one? Yeah, there is. Right over here. X-intercept, where y is equal to 0. Can you see our y-intercept where x is equal to 0? That's right over here. So y-intercept. So when x is equal to 0, y is equal to negative 6. And what is our lowest point on this graph? Our vertex. That's right over here. Okay, we can see the numbers start going up around that area. So that's our lowest point on this particular parabola. So we can actually go ahead and sketch the graph with these key points. And I'll show you how to do that. So we'll start with our x-intercepts. And we have one at -1 and 0. We have another one at 0, at 3, 0. So those are x-intercepts. Let's do our y-intercepts. I'll use the colors here that I used. We have blue here for y-intercept is when x is equal to 0, y is equal to -6. That's our y-intercept there. And our vertex is when x is equal to 1, y is equal to 8. And we use green for that one. So let's use green here. Now you don't have to color code yours. I'm just doing this so you can see for visual effects. And we have our points there. So we have a lot of our key points. And then we can just draw our curve around these key points. And I'll show you that. So we can start here and draw a smooth curve and come up the other side. So using our key points, we can draw our graph pretty easily. But how do we find these key points? This is what today's lesson is all about. Finding these key points so we can graph it instead of doing all of this calculation. So the first thing we want to do is look at the x-intercepts. We have x is equal to -1. And we have x is equal to 3. Those are intercepts. You notice any similarities between this and the original equation? -1 and 3. Let's see how these work. Let's try plugging in our x-intercept values into our equation to see what makes it 0. So let's plug in x is equal to -1. So we have our equation here. I'll just write that underneath. Y is equal to 2 bracket -1 plus 1 and -1 minus 3. So let's try this out here. So we have y is equal to 2. Then we have -1 plus 1, that's 0. And then this is going to be -1 minus 3, that's -4. And then if we tried multiplying this, we have 2 times 0, which is 0, times -4. So this ends up being 2 times 0, which is 0, times -4, which is also 0. So this makes our y is equal to 0. Let's try plugging in x is equal to 3 into the same equation and see what happens. We have 3 plus 1, and then we have 3 minus 3. And if we do this, we get y is equal to 2. This becomes 4, and this becomes 0 again. So we have 2 times 4, which is 8, times 0, that's just 0. And we can see our x-intercept values makes one of our factor brackets 0. And then when they're multiplied through, the whole equation just equals 0. So now we're going to see why this works. So why is this true? Remember, to solve for x-intercepts, we set y is equal to 0, and we solve. If a times b is equal to 0, then either a or b must be 0 to make it true. For example, if a was equal to 1 and b was equal to 0, 1 times 0 is 0. And if b was equal to 1 and a was equal to 0, we have 0 times 1 still equal to 0. So one of the two letters has to be true, one of the two variables. Likewise, if bracket a plus b times bracket c plus d is equal to 0, then either our first factor bracket, if this equals 0, and we multiply it to our next factor bracket, it'll give us a 0 answer. Likewise, if c plus d is equal to 0, and we multiply it to whatever value a plus b was, it'll also equal 0. So this must be true to make the equation 0. Either one of these brackets must be 0. A quadratic equation in the form y is equal to a x minus s close bracket bracket x minus t close bracket, or in other words, factored form, gives us the x-intercepts. The x-intercepts are also known as zeros. Let's try some examples and find the x-intercepts of the following equations. Okay, let's try number 1a. Here we have an equation y is equal to negative 4 bracket x minus 2 close bracket bracket x plus 6. We know whenever we're finding an x-intercept, we have to set y to 0. So let's go ahead and do that. We have 0 is equal to 4, negative 4 bracket x minus 2 bracket x plus 6. Since we're multiplying by negative 4 on one side, to get rid of that, we just divide it out on both sides. And so we're just going to get 0. 0 divided by negative 4 is just 0. And then this is just going to cancel out here. And we're just going to get x minus 2, x plus 6. So really that coefficient in front we can kind of ignore because we're just going to divide that out anyway. And then the next thing we have to do is to find what values of x will make this equation true, to make each bracket equal 0. And to do that, we can just look at each bracket individually. We can say, let's look at the first bracket here, x minus 2, what would let that equal 0? What would x have to be? All we have to do at this point is from our factor bracket, move that negative 2 to the other side. And in this case, we'll get x is equal to plus 2. And so if you plug plus 2 into this, it'll make that factor bracket 0. Let's look at the other bracket. We had x plus 6. If we make that equal to 0, we can solve for what x value would make this true by moving this over to the other side. So here we get x is equal to negative 6. So if you plug either of these numbers into our equation, it would make one of the factor brackets 0. And so we have found our x-intercepts. So our x-intercept would occur at 2, 0 and at negative 6, 0. Let's try another example. Remember, we set y to 0, and we can kind of ignore this bracket here. We have x plus 3, x minus 8. Then we just have to look at each of these factor brackets individually. So we have x plus 3 is equal to 0, or x minus 8 is equal to 0. And let's do the top one here first. We're going to move the 3 over to the other side. So we're going to get x is equal to negative 3. And if we move this over to the other side, we have x is equal to positive 8. So our two zeros, or x-intercepts, are going to be negative 3, 0, and 8, 0. Let's look at C. What values of x would make this equation 0? So the first thing we can do is set y to 0, 3x, 2x minus 1. So it's either going to be the 3x is equal to 0, and for this to be true, x has to be 0 to make 3 times whatever it is 0. So x has to be 0. And if we look at our next factor bracket, 2x minus 1 is equal to 0, then we just have to make x equal to 0. So we're going to move this over here. We're going to get 2x is equal to positive 1 when we move it over to the other side. Then divide both sides by 2 to get rid of the 2 on this side. So x is equal to 1/2. So our x-intercepts are going to be 0, 0, and 1/2, 0. Once we have our two x-intercept values, we can use these values to determine a few other features of our parabola. To determine the axis of symmetry, we need to find the midpoint between the x-intercepts. And this makes sense. Let's take a look. Say we had our graph here, and we had a parabola that looked like this, and we knew this value and this value our x-intercepts. If we found the midpoints, it gives us the x value of the midpoint here, which is our axis of symmetry, and the x value for the vertex, which is right there. Recall the midpoint formula from our analytical geometry units, where x mid is equal to our first x value plus our second x value divided by 2. Let's use these techniques to sketch a graph of a parabola. Example 1. Determine the y-intercept, zeros, axis of symmetry, and vertex of the quadratic relation y is equal to 2 bracket x minus 4 close bracket x plus 2 close brackets. Then sketch the graph. So basically everything that we've been looking at already. The first thing we can do is determine the y-intercept. To determine the y-intercept, we set the x value to 0 and solve. So let's go ahead and do that. We have our equation here, y is equal to 2. And wherever I see an x, we're going to set that to 0. 0 minus 4, bracket 0 plus 2. And using BEDMAS, we're just going to solve the brackets. So y is equal to 2, bracket minus 4 plus 2. And then we just multiply across. So y is equal to 2 times negative 4, which is negative 8, times 2. Y is equal to negative 16. Therefore, the y-intercept value occurs at 0, negative 16. So when x is equal to 0, y is equal to negative 16. Now let's determine the zeros, also known as the x-intercepts. To determine the zeros, we let y is equal to 0. A product is 0 only when one of its factors is 0. So we set each factor to 0 and solve for x. So we're just going to look at the factors again, like we were doing in our other examples. We have x minus 4 is equal to 0, and then we can solve for what x would be to make this equation true. We're just going to move this to the other side. So x is going to equal 4. Or if we look at our other factor, we move the 2 over, we have x is equal to negative 2. So the zeros occur at 4, 0 and negative 2, 0. So now that we have our zeros, aka our x-intercepts, we can solve for our axis of symmetry. Let me rewrite those down here. So we have x is equal to 4, that's one of our intercepts, and x is equal to negative 2. The axis of symmetry passes through the midpoint of the zeros, so we use the midpoint formula. So we're going to plug in those x-intercept values into this midpoint formula. So we have x mid is equal to 4 plus negative 2, our intercept values, divided by 2. And if we calculate that, 4 plus negative 2, that's just positive 2, divided by 2, that's equal to 1. So our x mid is equal to 1. So our x mid is equal to 1, and we know the x mid is equal to the axis of symmetry. In this case, the axis of symmetry is x is equal to 1. So we can conclude the axis of symmetry is x is equal to 1. Remember, we always state the axis of symmetry as an equation of a vertical line. In this case, x is equal to 1. Let's determine the last feature that we need to sketch our graph. Determining the vertex. The vertex lies on the axis of symmetry, so its x-coordinate is the axis of symmetry. If we substitute the x value of the axis of symmetry into the equation, the y value will be the vertex value. Okay, so we're just going to plug in our axis of symmetry value. We said the axis of symmetry was x is equal to 1, so we're just going to plug that into this equation and find what our vertex value is. So we have y is equal to 2, bracket 1 minus 4, bracket 1 plus 2. Again, using BADMES, we're going to calculate the brackets first. Y is equal to 2, bracket is going to be negative 3, sorry. And this is going to be 1 plus 2, which is going to be equal to 3. So let's go ahead and multiply. We have 2 times negative 3, which is negative 6 times 3. And then we have a y value. Negative 6 times 3 is negative 18. So our coordinate of our vertex is equal to 1, negative 18. So when our x value is 1, our y coordinate will be negative 18. So here's a summary of all those different features that we found. We found our y-intercept, which occurs at 0, negative 16, our x-intercepts, which occur at 4, 0, and negative 2, 0, the equation for the axis of symmetry, x is equal to 1, and our vertex, 1, negative 18. We can now graph out this parabola. So we have our y-intercept, which occurs at 0, negative 16, so 0, negative 16, that's there, that's our y-intercept. Our x-intercepts occur at 4, 0, and negative 2, 0, so 4, 0, and negative 2, 0. The equation for the axis of symmetry is x is equal to 1. We'll put that in a little bit after, and we're just going to do the vertex first, which is at 1, negative 18. So scroll down a little bit. So at 1, negative 15, 16, 17, 18, right over here. And now we can start seeing the shape of our parabola. So we can draw that in. Take your time when you're drawing these. Okay, and we know our axis of symmetry occurs when x is equal to 1, so we can draw that right down here. And there we have our parabola, without doing a table of values. Let's try another example. So let's graph the following quadratic relation. Y is equal to 1/3, bracket x minus 1, close bracket, bracket x plus 5, close bracket. And so we just need to find 3 key pieces of information that'll help us find all the different features, which is 1, we need to find our x-intercept or zeros. We need to find 2, our vertex, and this will help us find our axis of symmetry as well. And 3, we can find our y-intercept, but this one is optional. Unless the question asks you to find the y-intercept, you don't have to find it. You just have to do 1 and 2. In this case, we will find it, just so you have practice. So let's try it. So let's first find our zeros. So we just have to look at our factor brackets. We have x minus 1 is equal to 0, and then x plus 5 is equal to 0. And in both cases, if we move the 1 over, we get x is equal to 1, and our other value is going to be, if we move this over, x is equal to negative 5. So those are where our zeros are going to occur, when x is equal to 1 and x is equal to negative 5. So we can write those down as coordinates here as well. So those are our coordinates. And now let's find the vertex. So let's try finding our vertex and axis of symmetry. And to do that, we just use the midpoint formula for our intercepts here, our x-intercepts. So we know our x mid is going to be equal to 1 plus 5, or sorry, 1 plus negative 5 divided by 2. We can do that 1 plus negative 5, that's negative 4 over 2. Divide that, x mid is equal to negative 2. And that's our axis of symmetry. To find the vertex, we're just going to plug that into our equation. So we can take this value here, I'm going to plug it back into the original equation to get our y value. So y is equal to 1/3 -2 minus 1 bracket -2 plus 5. And we're just going to solve for what that is. Let's do the brackets first. So we have 1/3. This is going to be -2 minus 1 is -3. And -2 plus 5, that's +3. So we can just multiply 1/3 times -3. That's just -1 times 3. So y is equal to -3. So we can say our vertex occurs at x equals -2, y is equal to -3. -2 comma -3. And if we're going to find our y-intercept, we have to just plug in 0 for x. Actually, we won't find the y-intercept for this one. We'll just graph it using these points here. So we have our vertex, which is -2 comma -3. So right over here, that's our vertex. We have our x-intercept at 1 comma 0, and the other one at -5 comma 0. So we have something like that, and then we can just draw our parabola like that. It doesn't have to be perfect, and we know our axis of symmetry. If we wanted to draw that on here, we could do it, and we know it passes right through the middle of the vertex, where x is equal to -2. So here we have another example. Why don't you try this one on your own? Find the x-intercepts and the vertex and the axis of symmetry, and graph the parabola. You could pause the video here, try it on your own, and then resume to see if you got the right answers. So pause the video now. Okay, so let's find our x-intercept. So what two values of x would make this equation 0? So we just have to look at each factor individually. So we have -4x is equal to 0, and the other one is x plus 2. Right here, x plus 2 is equal to 0. And then we can solve for whatever x value is. So something times x equals 0, this x has to be 0 for one of them. And for this one, we're just going to move the 2 over to the other side. So we're just going to see x is equal to -2. So those are our two coordinates. And we can write those out as coordinates. So that's why our y is equal to 0. So 0, 0, and then -2 comma 0. Now let's find our axis of symmetry and our vertex. So to find the axis of symmetry, we use these two values and we just find the x midpoints. And so we have 0 and 2 divided by 2. So x mid is equal to our x values here. We have 0 plus -2 divided by 2. And when we do that, x mid, our vertex, is equal to -2 over 2, which is equal to 1, -1. And now we can plug this in. So this is our axis of symmetry. X is equal to -1. This is axis of symmetry. And then let's find the vertex from this. So we're going to use this value and find the vertex by plugging this value into the original equation. So y, so we'll say vertex over here. To find vertex, we're going to plug in -1 wherever we see an x. So we have -4 bracket -1 bracket -1 plus 2. And so we're going to do bedmess again. So we're going to solve what's in the bracket. For -1 plus 2, that's +1. And this is -4 times -1 times 1. So if we do this, we have -4 times -1, that's +4. Multiply across. So our vertex is going to be at x -1 comma 4. That's our vertex. And what the hey, let's find the y-intercept. Let's do 3 y-intercept. And to do that, we just set x equal to 0 and solve for it. So y is equal to negative 4x, bracket x plus 2, and if x is equal to 0 here, the y-intercept will be, just looking at this, we can already tell, since there's more multiplying by 0, it's also going to be 0. So let's graph these points right now. So we have our zeros, or x-intercepts at 0, 0. There's one there. Our other one is at negative 2, 0. There's there. And our vertex is at negative 1, 4. Okay, and we also saw our y-intercept occurs at 0, 0, so it's the same point. And we can just draw our parabola now. So much quicker than doing all those calculations for the table of values. Let's try our last example here. Example 3. Find the quadratic expression given zeros at negative 2, 0 and negative 1, 0 and a y-intercept value of 0, 10. So this one's going a little bit backwards. So instead of drawing out a parabola, we're given the key features and we want to write the equation for this. And the easiest way to do that is to express, given the information that we're given, is to express it in factored form. And if you recall, it's going to be equal to y is equal to a bracket x minus s bracket sx minus t, where s and t are our intercepts. Our s is equal to negative 2, and our t is equal to negative 1. So we have some information that we could already start filling in, and so let's start doing that. So we have y is equal to a bracket x minus s, which is negative 2, close bracket, and then x minus, t, that's a bracket. Okay, and so we can simplify that in the bracket already. We have those double signs. We can just, two negatives make a positive, so it'll be a bracket x plus 2, bracket x plus 1. Okay, so the only thing that we're missing now is the value of a. And we could actually solve for a by using this up here, the y-intercept value that's given. We know that y is equal to 10 when x is equal to 0. So we can plug this information into our equation that we have so far. So y is equal to 10 when x is equal to 0. Okay, and now we can just solve our brackets. So a is going to be 2 inside here. It's going to be 1, and the 10 is still out here. And now we can solve for it. So we can multiply these two here. So we have a times 2 is equal to 10. And then we just have to divide both sides by 2 to solve for what a is. So we divide that by 2, this side by 2. So 5 is equal to a. So once we have our a value, we can state our final equation. Y is equal to 5 bracket x plus 2 close bracket x plus 1. And so that's how we would figure out what our equation was given this information above here. So we just plugged in our values for s and t, and we just plugged in our value for the y-intercept and solves for what a is. So you have a lot of practice. I think this is a key lesson in this unit. So spend a lot of time doing these homework questions and make sure you know the ins and outs, and you'll be fine with the rest of this unit.